So good evening all. Welcome to the NPTEL course, Matlab-Based Programming Lab in Chemical Engineering. So this course is first taken by Professor Parag Deshpande from the Department of Chemical Engineering. This was made when he was working in IIT Kharagpur. Right now he's in IIT Jodhpur. So I am a PMR fellow, which is Prime Minister's Research Fellowship. So I am from the Chemical Engineering Department of Indian Institute of Technology, Kanpur. So I'll just give you a briefly an idea of how this problem solving sessions will be happening for this NPTEL lecture. So basically this will be a 2 hour session. So every Friday we'll have from 6 to 8 p.m. And what we are trying to do during these sessions is that for the first maybe 1 hour or 45 minutes, depending on the course contents that we have discussed, we'll try to do a quick recap of whatever we have done in the current week. So I expect you to go through the recorded lectures that has been already published in the NPTEL website. Go through that, and if you have doubts or something, you can ask me during the live session. Okay, so that will be the first part. We'll do a quick recap. I'll be always reiterating the important points that we discussed in the previous week. And after that, the next 1 hour, the next half of the session, what we'll be doing is we'll be trying to solve problems. So I'll be trying to solve problems that you can expect during your assignment sessions. So you would have got your first assignment where you have got like a lot of multiple choices questions. So I'll also be giving you such questions, and we'll be also doing some programming assignments. So basically, I'll give you a question and we'll have like a 2-3 minutes to think about it. And then if you have answers, you can put them in the chat box. Or if you have questions in between also, you can just unmute yourself and ask me. Okay. So this will be how the course will be handled during this live session. We also have another live session. I think it's on Tuesday. So both Friday and Tuesday, though it is taken by two different people, we'll be covering almost the same thing. So do you have any questions or something before starting the session?
Hello.
Yes, sure.
Yes, ma'am. I wanted to ask that on Tuesday, same doubt session would be there of uh, about week one only.
Yes. So both Friday and Tuesday we'll be doing the current weeks. Okay, so right now I'm doing the week one session. Tuesday also it will be the week one session only, but it will be taken by two different people. So this time I'm taking, and the Tuesday we have another TA taking it. We'll be covering the same topics. Maybe the practice questions that you get might be differing. So what you can do is whichever time that is suitable. If you're free on Friday 6 to 8, you can attend this session. If you're free on Tuesday, I think it's 6 to 8, you can attend that session. Both of us will be uploading our recordings in the NPTEL website. But the problem is, I'll be sending the recorded lecture to the NPTEL team, and the NPTEL team has to it may take some time, a day or two. So I'll always recommend that you join the live session so that if you have any doubt, it is just cleared then and there itself, or else you'll have to go back and then sit and listen to a 12-hour recording. Okay. So as much as possible, try to attend the live sessions. But anyway, the recordings will be shared with you. Um, Sorry, there was a problem with sharing. Yeah. And also, since this is our first class, in case there is a problem with the presentation, if I'm not sharing it properly, or if there is a problem with the audio, please do let me know. Okay. Is there any other questions you have? Can we get the can we get the recorded video later? Yeah, of course you can get the recorded video later. But as I said, it may take a day or two. I'll try to put it as soon as possible. So yeah. So if there are no other further questions, can we proceed to the lecture? Okay. So moving forward, as I said, the first half, we'll be trying to give a quick recap of the theory that we learned in the week one. So as you know, the whole chemical engineering programming will be doing on the MATLAB software. And the MATLAB, the name comes from the word metrics laboratory. So from the metrics, we have MAT, and the laboratory, you have the lab part. So that's how the MATLAB name was coined. And the first commercial version of the MATLAB was released in the year 1984 in the Automatic Control Conference that was held in Las Vegas. And you also have like the uses of MATLAB, which is this is like some basic uses like numerical computing. You can have controls, and signal processing. You can also do data analysis. So now, with the what is the motivation behind having a course like this? Why use MATLAB for doing chemical engineering programming? So mathematical modeling is a key to chemical engineering design, operation, and control. So basically, when we are trying to do programming, we have like two key questions that we have to answer. So I hope you all are from chemical engineering background. Is there anybody who's not there from the chemical engineering background here? Okay. So if you're not from the chemical engineering background also, please do let me know. Okay. So then we can brush up the little bit of the theory part also. And also, if my speed is not okay with you, please do let me know
Ma'am, I
because
am from the chemistry background.
yeah, okay. Chemistry background. So we'll see as the week progresses, you will get to know what kind of topics we are discussing, right? So if you're not comfortable with it, you can just let me know, and maybe if you have any questions, I can answer that. Okay. So this week will not be specific to any domain. It is just general motivation of why do programming. It will be a general session of why do programming using MATLAB. And okay, one more thing, if my speed of the slides is not okay for you, please do let me know because since it's our first session, it will take some time for this to get settled down. So the first key question what we have is, can every problem be solved analytically? So you know that every chemical engineering problem, whether you are designing a reactor, whether you're doing material balance, energy balance, like all those things, we have an analytical equation that is given to us. And you can solve it by hand, just like we do it for our exams. Okay, is it possible to solve it like that? Actually, yes. But the problem is it wise to solve every problem analytically? It is not usually preferred that we solve every problem analytically because imagine that you're going into a chemical engineering plant. There will be a lot of small systems. You will have the reactors. You will have the this flowchart that is given. Okay, you start with the raw input. We will have a lot of raw materials, and the raw materials will have to undergo a lot of physical operations. Okay, maybe it can be like the size reduction, maybe you will have to melt the product, or maybe you'll have to convert into a volatile gas substance or something like that. So there can be pressure, temperature changes. You might have to mix two or three components, so there is change in composition. Maybe you'll have to reduce the size of the component, so there is size and size distribution happening there, density, viscosity changes. So there are a lot of physical operations associated with it. Can we solve all this analytically? No, it may not be humanly possible to do everything analytically. And now coming to from the physical operations, so you have the reactor, where will there be a lot of different kinds of chemical processes that are happening. And that is also very difficult because in a chemical industry, there is like inherent like temperature and pressure fluctuations that can happen. There might be impurities in your raw materials. Accounting for all that is like humanly not possible. Okay. And again, once the reaction is over, also you have a lot of physical operations coming. What are these physical operations? Like I said before, there could be like temperature fluctuations, pressure changes, composition changes, size, distribution changes, density, viscosity, all those things could change. And again, once all the physical operations are completed, we have the final processed output. So since we have in the chemical industry, we have a lot of small reactions or small processes that are happening. Solving each of this block analytically is not recommended. Okay, so for that, it is always useful that we use the softwares which have this small sections already coded. It makes our life much more easier. Now, I'm just showing you some basic examples why we require all this MATLAB programming and all those things. So here you can see like the temperature change, okay? The temporal model on the spatial temporal model or the spatial models. So what's the temporal model? Temporal model means we are independent variable and there is a dependent variable. So the dependent variable only depends on the time. Okay, so the time is the independent variable here. So here you can see how the temperature is fluctuating. The temperature drops from time from the temperature T to an ambient temperature that is T infinity. So here you can see this here T is a dependent variable and T is only dependent on the time factor. So this is just a equation where equation depending on time. On the other hand, here you can see here the temperature depends on both your time and your spatial coordinate. That is, if you're talking about a fin, okay, a fin has like the x, y, z axis. Also, you can see that the temperature drops as the time progresses. So now here the temperature fluctuation will be a function of both time and your x, y, z coordinates. So this is a spatial temporal model. And then you have the spatial models where the temperature is only dependent upon your XYZ coordinates. So what are these equations basically? You can see this is an ordinary differential equation. Okay. And this you can see is a partial differential equation. That is, it is dependent on both time and then it's dependent on the spatial coordinates. Again, you have like partial differential equations. So these are called as ODEs and PDEs. So ODEs and PDEs, you have it can be further divided into two kinds of problems. One is IVP, that is initial value problem, and the other one is BVP, boundary value problems. Okay, so we have two category, ODE and PDE, and again this can be divided into the IVP problems, BVP problems, and also actually there are different kinds of ODEs also. Okay. So solving all this analytically, you know how to solve this. Okay. If you have the limits, that is the boundary value conditions, you can integrate it and find how the temperature varies for different time intervals. Okay. You can do that. But if you have to do for a larger system and if your equations gets more complicated, like I said, in a chemical industry, you'll have lot of small processes. You'll have to compute for all the process. It's difficult if you solve it analytically. So for solving such equations, for solving ODEs, PDs, whatever kinds of problems they are, we have already existing routines in MATLAB that will help us to solve it. Okay, so for example, in MATLAB, there are different kinds of ODE solvers, like ODE, the ODE 15 years, ODE 23 years, and all those things. So just a second, I'll just quickly try to show you a glimpse of it. Just give me a second. Okay, can you guys see MATLAB? Just before that, let me just ask you, is there anybody who doesn't know the basics of MATLAB? If yes, let's just put a message in the chat box. Okay, I just want to get an idea of like what percentage of the participants know MATLAB, or should I take it from scratch? Okay, somebody has messaged no, like, sorry, I didn't get you. Is it that you doesn't know MATLAB, or do you know MATLAB? I didn't understand what that moment. Okay, fine. Yeah, fine. Sure. So I'll tell you one more thing. Right now, I'll just give a quick basic of the MATLAB output and how to run a MATLAB code. Okay. So for example, this is how the MATLAB looks like. If you are in some institute, your institute will have a MATLAB license. For example, I am from IIT Kanpur and I have an IIT Kanpur license. So I'm using MATLAB. So you can go to MathWorks. It's a website name. So from there, you can download the recent version of MATLAB. I think this one which I'm using is MATLAB 2023A. There are like 2024, the newest versions are also available. You can just download. You have to give your institute mail ID and you can get the access to this MATLAB. Okay. If else, if you don't have a MATLAB license, you can always go to MATLAB online. Okay. So you just go to Google and just type MATLAB online. You will get an online portal. Okay, that is coming. Okay, so let me see if I can show it to you. Just give me a second. Mm, Yeah. Okay. Can you guys see this? I've just searched MATLAB online and you will see here open MATLAB online. Okay, here also you'll have to enter some mail ID. And for time being, I'll just enter my mail ID here. Yeah. So this is how an online MATLAB looks. So let me just see. Yeah, open MATLAB online, click on that. It will take some time. The problem with this MATLAB online is you'll require active internet connection. Okay. So if you have MATLAB license, it's always better that you download the MATLAB app because that doesn't require an active internet connection. So this looks exactly the same as MATLAB. Every icons, everything is the same. Okay. Just that by using this, you'll require an active internet connection. So this is a last resort to the people who doesn't have an active MATLAB license. Okay, now going back to the MATLAB, I'll just quickly explain the different sections of MATLAB. Okay. Okay, so this is the home. Okay, and then you can see here new script. Okay, I hope I'm sharing it properly. So let me just close it. And yeah, in this new, you can see a lot of things like new script, new live script, new function and everything. Okay. Usually we work with a MATLAB script. So let's just click it again. You can see a editor window that is opening. Okay. So this is the default setting. You have the toolboxes here, all the different tools. Here, this current folder tells you which folder you're working in. So it's always better if you're, for this course, I'll tell you just create a folder. Okay, for example, I've created a folder called a CHE programming. Okay, and you open the CHE programming and then you work with it, work with MATLAB. Okay, what happens is whatever files you save will be automatically saved in the CHE program. This is just to be organized. Okay, when you're trying to code, you don't want the code to be scattered all around your computer. Next is you open a fresh MATLAB script and here you can type the commands. For example, 1 plus 2 and things like that you can enter. And how do you save it? You go to the save and you save as, he'll ask you for a name. Let me just enter file or something and you save it. So now you will see the file is saved in the CHE programming as trial.m. So every MATLAB file will have this .m extension. Okay, that is what that indicates that it is a MATLAB file. Now this is the editor window you have here where you enter all the commands, and this is the command window. Okay, so I'll just tell you what's the basic difference between a command window and editor window. In command window, you can enter the same commands 1 plus 2 equal to 3. Okay, and here this is the workspace. So whatever so here I just entered 1 plus 2 is 1 plus 2 and I didn't assign any variable to store the answer for this. Okay. So MATLAB, what it does is if you don't yourself assign a variable to store the value of some computation, MATLAB automatically takes the variable which is called as ANS, okay, for answer and stores your answer in this variable. Okay, so that's what happened here. I just entered 1 plus 2. I didn't give any variable. I didn't give any variable name to save the value in it. So MATLAB automatically saved it in ANS is equal to 3. And that you can see here. Okay. Workspace gives a list of the variables and their associated values. So here you can see answer is 3. So for example, right now I'm entering A equal to 1 multiplied by 9 multiplied by, okay, 7. Okay, 63. Now you can see the workspace A is equal to 63. So there is a difference. Now we might ask, like, what is the difference between a command window and an editor? Like, sorry, a MATLAB, uh, what do you say, script. Okay, what is the difference between these two? So you write a MATLAB script if you want to save your commands. For example, I wrote 1 plus 2, I wrote 63 and everything. Now I'm just clearing the MATLAB screen or maybe I'm closing the MATLAB. Okay, let me just close the MATLAB or for clearing the screen, you have a command which is called a CLC. Okay, you will see everything will go right now. See CLC. If you want to clear the workspace, there is a command which is called as clear. Okay, you will see everything is cleared here. Okay, now if it is cleared, tomorrow you're coming and you want to use the commands which you used yesterday. Okay, you may not have access to it. Okay, 1 or 2 commands you might be able to remember. But what if you're writing a 10, 15 lines of code, or maybe a code even bigger than that? Okay. If you have a code, a proper code that you have to save and use it in future, don't write that in the command window. You make a MATLAB script, you open here, go to new, write a script here, and you here save it. Okay, save like 2 multiplied by 3, 4 multiplied by 6, or something like that. You save all the commands here and save it here. And you may close it. You may close MATLAB also. Come tomorrow and then try opening file.m. You will have all the commands. Okay, so if you're trying to code, if you're trying to code like 10, 15 lines of the code, it's always recommended that you write a MATLAB script. Now there is a different thing which is called as a MATLAB function. Okay, a MATLAB function is a MATLAB script will just execute a series of commands. Like here I've entered 1 plus 2, 2 multiplied by 3, 4 multiplied by 6. These are just a series of commands which will be executed one after the another. Okay, but what if I want to take a input from the user and I want to output something to the user? Okay, if that is required, then I make a MATLAB function. So you can go here, new MATLAB function. See, this is how a MATLAB function looks like. So this might be a quick, recap to how MATLAB works. If you don't understand it right now, okay, don't worry, because next week we'll be completely dedicating it to give a idea of MATLAB. Okay, I'm just giving a quick insight into it. So here the function starts with a keyword function, and these are the outputs that this code will be giving you. The function name, it should have a name with which it is identified. So it is called as untitled3. And these are the inputs that the function take. Okay. Right now it is taking 2 input. If you only want 1 input to be taken, you can just delete this. Okay. That is fine. Then you will have a series of commands entered, just like you wrote in a script. And you have to end the function with the keyword end. So this is how a function works. Okay, so in a MATLAB script, you write a MATLAB script when you have to just when you have to just execute like a series of commands. But if you want your code to take a series of inputs, give a series of outputs, okay, in that case, you always use a function. Function also has several other uses, which will come later, okay? Right now, let's not pile all things up. Functions are also having several other duties to do, which we'll discuss in the future. Okay. So now if you want to run a function, you have to save the function and then you have to click on the run command, or else you can call the function by its name. Okay. These are the 2 things you do. We'll come to this later also. Right now, do you have any doubts? Okay. Okay. Now we'll just quickly go back to the record. Okay. Just a second. So, as I said earlier, there are different kinds of ODEs and PDEs. Now, if you want to know what MATLAB can offer to you in this case of ODEs and PDEs, okay? Or if you don't know anything in MATLAB, there is always a thing which is called as, am I sharing MATLAB? I think I'm sharing MATLAB. Okay, can you see here something called as search documentation? Okay, go here, this is written search documentation, okay? Click on, I don't know what MATLAB can offer me in the field of ODEs. So let me just type ODE and you press search or enter, okay? Yeah, can you see this? MATLAB opens a web page like this, okay? Now you can see several search results that have come. Now let's go to choose an ODE solver. See, now here you will see ordinary differential equation. It has given an example. It could be like a first order ODE. It could be a second order ODE. Okay. So it could be like multiple ODEs, a system with multiple ODEs. Okay. Higher order ODEs. How to solve this? Complex ODEs and all those things. So MATLAB gives you example. MATLAB gives you a code how to execute such systems. Okay. And also MATLAB has several ODE solvers, okay, which you can choose an ODE solver according to your problem. So you can see the ODE solver 45. When do you use it? So this is the most general ODE solver. ODE 45 should be the first solver you should try. And then you have ODE 23. When do you use ODE 23? ODE 23 can be more efficient than ODE 45 at problems with crew tolerance, all in the presence of moderate stiffness. So like this, we have like several ODE solvers. See? So why am I showing you this is because MATLAB, where if you're getting stuck somewhere, you can use MATLAB itself to guide you. Okay, you can just type some keywords, you can find the search results, go through this, and MATLAB will give you examples and see snippets of codes which you can try. So for learning any programming language, it is very important that you try it by yourself. Just by listening to the lectures or just by listening me talking or the professor talking, you'll not be able to learn this. Try to code, write small snippets of code, try to execute it by yourself, and then slowly, slowly we'll pick it up. So let me just close this. Yeah. Mhm. Yeah. So as I said earlier, now we have different kinds of ODEs and PDEs. So this is a small recap of what was taken in the recordings. So we have spatial temporal models and how we can solve we can try to find the numerical solution for partial differential equation, which are initial value problems, or also you can try to solve linear algebraic operations. Also, if you have just spatial models, which could be even in the higher dimension, we can find using MATLAB, you can find the numerical solutions for boundary value problems and also linear algebra operations. And spatial models in one dimension also you can solve for boundary value problems. And then the differential equations are called as ordinary differential equation. Okay. Partial differential equation means you have more than one independent variable. Like here, you have an independent variable time and you have an independent variable x, y, and z. Okay. When there are multiple independent variables, you call it as a PDE. If you just have one independent variable, it is called as an ODE. Okay. So ODE also boundary value problems, we can solve it using MATLAB. Now, another field where the softwares can be used is when you have to optimize, whether you have to maximize something, whether you have to minimize something, then also you can try to use MATLAB. Okay. For example, in this whole thing, there are several factors that is coming. Okay. But you'll have to take care of the steam cost, you'll have to take care of the capital cost, the reflex ratio, and all those things. And what if your objective is, the main objective is to minimize the total cost. Okay. So how do you handle this problem? You can write equations and you can try to solve it using MATLAB. So here also I'll just quickly show you what MATLAB can do. Just a second. Yeah. Here also I'll just write here minimization. Yeah. You will have a web page like this. Okay. Now you have like unconstrained minimization. What if you don't have any constraints? Or minimization with gradients and Bezier. So let's go to unconstrained minimization, which is a basic minimization we do. Then MATLAB have functions that can help you do it. So one of the example is fmin UNC. This is function for minimization. UNC stands for unconstrained. Okay. You have examples. You have some problems like this. Find the minimum of this equation. You'll have an example of how to solve this and all those things. Okay. This I'm just showing you one example like this. So likewise, for all the operations that you see in your chemical engineering world, the small segments you can break down and you can use MATLAB to solve it. Just a second. Yeah. Okay. Now the next thing what we have is called a symbolic algebra. So symbolic algebra means just look at this side of the equation. Okay. This is a definite integral of 1 divided by 1 plus x squared dx. So just a second. Can you tell again from where you have to locate maximization? No, what I'm trying to say is in the previous graph, Like this is right now, it is cost minimization or cost maximization. Okay. Here you have different factors like the steam cost, capital cost. Maybe in a real world system, we will have to take care about the raw material cost and all those things. And maybe the ultimate aim will be reduce the total cost or reduce the transport cost. Okay. So this will become an algebraic equation. Okay. There might be several factors you have to take into account, and you will have to ultimately minimize one thing. Okay. So for such problems also, if you're able to mathematically formulate it, MATLAB can help you solve those equations. Okay. So I just gave you an example of a function in MATLAB that can help you solve it, which was called as the F-min unconstrained. Okay. So where you can solve unconstrained minimization problems. That is, unconstrained means there is no condition. Like for example, you have an equation in X and there is no condition that X has to be between 0 to 1, or no such constraints are there. Then in that case, you can use that function, which is fmin unc. There are several other functions also. We'll come to that like one by one, okay, as we solve the problem. Right now, I'm just showing you what is the potential of MATLAB. Okay. So as I said here, we have a symbolic algebraic equation. That is, what I meant is here in this side of the equation, how do you solve it? You know the integral of 1 divided by 1 plus x square. Okay. Once you get the integral, then you apply the upper limit and the lower limit, and then you get a final numerical answer, right? So here for this case, you get a numerical answer. Similarly, for this case, okay, this is a matrix with all entries are numbers. If you want to find the determinant of this matrix, okay, you can numerically find it, and finally the answer will be a number, right? So in this case of definite integral and this matrix case where all those are numbers, you will be getting a final answer as a number. Okay. But what if this case if you see, okay, this is a limits, integral limits are not given here. So when you integrate it, the answer what you get will be a function of x, right? It will be a function of x. Similarly, this equation that you see, so this matrix that you see here, you can see here there are multiple variables. A is a variable, B is a variable, C is a variable. These are unknown quantities. You don't know what are the values of this. Okay, now if you want to find the determinant of this matrix, it will be an equation of A, B, and C. Okay. Whenever you're getting equations where there are unknowns, then those are called as symbolic algebra. In MATLAB, there is the way you can solve the symbolic algebraic equation. It need not be always numbers. Okay. You can give an equation of x. Maybe if MATLAB will help you how to find the value of x. You can equate that to 0 or something, and MATLAB can help you find the value of x. So symbolic algebraic equations can be also solved using MATLAB. Apart from MATLAB, in the recording, sir has given you two more examples of softwares, which is Mathematica and Maple. All those things, all these softwares can also help you work with symbolic algebraic equations. Now, let me just see if I can help you with that. Okay. Either you can go to this box here and search for keyword. If you don't want to do that, you can type here. Okay, the keyword is help, and then you type some keyword which you want to search for. For example, I'm typing SYM. Okay, this stands for symbolic. Yeah. Now we will see something that has come. Okay. Sim. What is sim? Sim constructs symbolic numbers, variables, objects. Okay. Sim A constructs an object S of class sim. SYM stands for symbolic. Okay. In MATLAB, SYM stands for symbolic. Okay. If input argument is a string, the result is a symbolic number. There is a lot of other things you can work with it. Okay. For example, earlier you saw F min unconstrained, no? So I just want to know how to use it. I want to know how is the syntax of it. So let me just type F min unconstrained. See, it clearly gives you how to work with it. So you'll see F min unconstrained. This is the syntax. You have to give a function. You have to give a starting guess. There are other options that are available. If you go down, it will give you an example. Okay. This is an example. And if you want further options, you can always click on this, any of the blue ones. Okay. These are links which will take you to the earlier web page which I showed you. Okay. If you just click here, or if you click for documentation for F-min and constraint, it will go to the earlier web page which I showed you. Okay. Or else if you don't want to go to the web page, if you want to quickly find it, and the keyword. Okay. In case I'm not audible, please do let me know in the chat box. Okay. Now, again, recapping what is the need for programming. This is what we were telling in the beginning of our lecture. That is, here you have like a whole reaction system that is coming here through a filter and is going to multiple compressors and it's going to a reactor. And you have ammonia that is going through a vaporizer and again going to the reactor. So maybe you will have to handle how the things are happening in a compressor. Maybe you'll have to do a balance for that. Here for the vaporizer also, you will have to do some balancing. Again, for reactor, you'll have to understand how the concentrations are varying, the temperatures are varying, the pressure are varying, everything. And from again, here you have the steam reactor, cooler, condenser, and here you have a column that is separating your gases. Okay. So here what you can do is you can give the small boxes like a vaporizer, filter, all those small boxes can be separately coded and you can do separate material balance, energy balance, and everything with the help of MATLAB. Okay. So once you have a problem, how do you try to solve it? So first, what we do is we try to model our system. Okay. We first try to model our system and try to identify in what category that falls in. Okay. Is it like an ODE, PDE solving? Should we solve an ordinary differential equation? Or is it a minimization problem? Or is it like, okay, working with matrices, you need to find the determinant of the matrix. Like, what kind of problem is that? What kind of mathematical category does your system falls under? Once you have decided, okay, this is this kind of a problem. Maybe it is a regression problem. Okay, that is maybe you have like a lot of data. For example, if you're doing experiments in a lab, you will have like you're trying to identify how the concentration is varying with time. So with your equipment, you're telling that, okay, time t equal to 0, the concentration is so and so. At time equal to 1 second, the concentration is this. Time is equal to 10 seconds, the concentration is this. You have like a time and a concentration table. Now you have to see how this concentration and time is related. So you need to create a function that relates your concentration and time. Okay, so fitting a function is called a regression model. Okay, you're trying to find the best fit function that can also be found using the MATLAB software. Okay, so first identify what kind of problem is your system, then identify the proper numerical techniques that are available in that particular category. Once you've identified your problem, then there are several methods that I said earlier. If you want minimization, there is fmin unc is there. Just a second. Am I audible?
Yes, ma'am.
Okay, thank you, thank you. So once you have identified your problem, you see, okay, what kind of numerical techniques you have to use. For example, when I showed you ODEs, you saw like 1 million ODEs that has been cited, right? ODE 45, ODE 23, and everything. And everything can be tailored according to your model. In some cases, ODE 45 would be the most suitable method. In some cases, ODE 23 could be the most suitable methods. Okay, we'll come to each of that. So once you have an idea, okay, so these are the things that is available to you. Then according to your model, it is your decision to choose the numerical techniques that is suitable for it. Once you have selected the numerical technique, then you need to implement it. So for implementing it, using the most fundamental mathematical operations and program control flow. Okay, what we meant is that, okay, so what you have to do in a filter, what you have to do it in a vaporizer, what you have to do in a reactor might be different kind of operations. Okay. Once you have just tabulated, okay, this is what I have to use here. You use the small codes that are available, like the small functions that are available in MATLAB to find all these values. So using this, what are the freedom that you get? You can do a material balance, you can do energy balance of a system. You can maybe predict the product composition, steam load, the power requirements, thermodynamic calculations, dynamical responses, control designs. So this is just a few example of things that you can do using the MATLAB software. Now you've seen MATLAB, okay? Now there is a totally different class of softwares, which is called as process simulation packages. So process simulation packages means this is dedicated to, and right now we will be talking about a software which is dedicated to us chemical engineers. Okay. So what does it do? In chemical engineering, in such software packages, what happens is the package is designed in such a way that it is applicable to a certain kind of problems. Okay. For example, what we're trying to talk about is about Aspen Tech. Okay. Aspen Tech, many of you might know, Aspen Tech is a software which has Aspen Plus, Aspen Hysis, and all those things. So what do you do is in Aspen Tech and Aspen Hysis, you can design a flow chart. Okay. You can design a reactor. Okay. You can design a compressor. You can design a reactor. You can design a vaporizer. Okay. In that, what do you do is it will, if you just try to open Aspen Plus or Aspen Hysis, you can select, okay, what is the unit operation I'm trying to do? Okay, I'm trying to make a reactor. So you can select the reactor. You can choose. So it is just like you're selecting options. It may ask you what you want. You select a reactor. Then you'll have a drop down menu where you will be selecting what kind of reactor is there, what is the temperature, pressure conditions. You'll be just entering those values. Okay. And it'll be like, okay, these are the equations that are governing this reactor, and rest of the calculations will be done by the package itself. Okay. You don't have to write codes for it. Already the codes are written in the background. You have to just give the code your input values, maybe the temperature condition, pressure condition, the sizes, and all those things. Okay. So the such simulation packages are very, very useful when you are using like the industrial design and everything, that things are very, very useful. But the problem with using simulation packages is that it is like a black box. Okay. You are giving the values and the package is giving you some answer, but you never know what is the underlying maths behind it, what is how it's been solved, because you are not the one solving it. Okay. So using simulation package is always nice, because when you have to solve for a very big system, you can't keep solving like every small part using Matlab. Okay. For that, you'll have to use dedicated software such as Aspen Plus or Aspen Hysis, or there are like several other softwares that is available. Okay. For example, earlier, if you remember, during my engineering days, I used to draw this engineering drawing in pen and paper. Okay. But now we have softwares, which is like AutoCAD and all those things, which makes our life much more easier. Okay. So you can always use the process simulation packages. But as I said, it will be like a black box. It will not be equivalent to us solving the problem. So these are the simulation packages, and these are like the wide range of simulation packages that are available. So what can you do? So understand that each of the simulation package has an assigned duty. Okay, it can only do that for you. Okay, what Aspen does, your AutoCAD doesn't do. Okay, what this answers about Fluent does, the Autodesk cannot do. Okay, so it's very, very specific. The tasks are very, very specific. So you can have thermodynamic property. Yeah, any questions? Okay. So you can model thermodynamic properties. You can have pump and piping models. You can have heat exchanger models, separation process models, process optimization and economics, and all those things. Okay. For all this, you have like separate packages. We can use that also. Okay. Now, okay. So let's keep this process simulation package aside, because that's not what this course is all about. Right now, we are studying a programming language. What is this programming language? Programming language means you are writing codes by hand. Okay. Matlab might have some inbuilt commands to help you with it, but still you will have to write a routine. Okay. Of how to work with it. Excuse me. See, as I said here, I had a question, which is Aspen or AutoCAD is easy to access. See, it's different. Okay. Aspen and AutoCAD, it depends on what kind of systems you're working with. It depends on what is your objective is. Okay. So depending on your objective, Aspen and AutoCAD doesn't do the same thing. Okay, it depends on what kind of software is suitable for your problem. Okay, and apart from using the packages, I always, okay, my earphones just died. I hope I'm audible. Yeah. If I'm not, let me know. Yeah, thank you so much. So, as I said earlier, just give me a second.
So as I said earlier, this programming languages will have its own like some inbuilt functions for you, but you will have to write a set of commands. So this gives you a lot of freedom, okay, because you know how to program it. Okay, it's the commands you what you write, you will understand what is the underlying reaction chemistry and everything. Okay, you'll understand what are the commands you are using, what are the equations you are using, but this will be a much more difficult route than using the already existing simulation packages. And also in MATLAB, it's like basically using a calculator. Okay, you can use it for a variety of things, but just that you can only process like small parts of it, and finally you'll have to combine everything to make a final, maybe like a flow chart or a whatever an industrial process that we saw earlier. Now since we have like lot of languages here you can see GNU, Octave, COBOL, Visual Basic, Pascal, SQL, Logo, and all C++, R, C, and all those things. Okay, these programming languages can be categorized into two categories. One is compiled languages, another one is interpreted languages. What's the difference between these both? Compiled languages means whatever code you write. Okay, it's called as a source code. What you write, what happens is in the compiled language, the source code will be converted into a machine code. Okay, and in one go, that is from first line to the last line, first the whole code will be converted into machine code and then it will be executed. Okay, but on an interpreted language, what happens is each line of the source code is translated into machine code and it is executed. Okay, after the first line of code is executed, second line is again converted into machine code and executed. Okay, it is line by line execution. But on the other hand, compiled languages, what happens is the whole code first you convert into machine code and then execute it at a one go. Okay, now what is the other differences? Execution of code is the fast because of the executable file. Okay, here the execution of the code is much more faster because once the entire code has been converted into machine code, then execution happens within seconds. Okay, but here what happens? Here there is line by line conversion into machine code and then execution. So because of that, compared to the compiled languages, the interpreted languages can be a bit slower. Now, error in the code results in the failure of the compiling the code. Okay, since as the whole code is compiled at once, if there is an error at the second last line or something, the code might not even run because the compiling has to be successfully done. Only then the whole code will be executed. But on the other hand, in interpreted languages, what happens is you imagine that you have a mistake in the fifth line of the code. Okay, in that case, the first four lines of the code will be executed. You will be getting answers from the first four lines of the code. But in the fifth line, your compiler will stop because there's an error there. Okay, so here this why do we use interpreted languages then? So if you're working with like large systems and you have like small blocks of code, what you do is instead of compiling the whole thing at one go, you try executing small boxes. Okay, small boxes, just check, okay, is there an error in this portion, is there an error in this portion? You execute small portion, boxes, and finally you will get the final result. So the thing is, if there is an error, it is easy to track when you're running with interpreted languages. But on compiled languages, since the whole code has to be compiled first, even if there is an error, it might be difficult to track. Now there are cross-platform compatibility issues, and this has better compatibility. Now I'll give you like some example of the compiled languages. Some compiled languages are the basic C, C++, and Fortran that you see. Interpreted languages are not. Any questions? Dave? If you don't have any questions, please unmute yourself to let disturb other people. Okay. So we have C, C++, and Fortran, and here you have Matlab and Python. Matlab and Python is a very user-friendly software. Okay. Python, if you have worked with Python before, you might know that Python, you can just compile it with different softwares, okay, different commercial softwares. For example, I work with softwares like WASP, Gaussian, and everything with which Python can be easily blended. Okay, so that's what is called as cross-platform compatibility. Interpreted languages are more compatible compared to the compiled languages. But understand that this MATLAB basically is a software that is based on C programming. Okay, so compiled languages has like its own power. Whenever you're coding a new software, it has to be done in any one of the compiling languages. Like I said, MATLAB is based on C. So compiled languages have its own like advantages, but like it may not be very user friendly. Okay. Now here we have like two cases. This has been given in the recorded lectures. I hope you guys have understood. In case you have any doubt, I'll just explain this once more. Okay, so here there are two cases. Here we are trying to understand which kind of language should we use, whether we should use compiled language or interpreted language. For example, in the case one, it is intended to stimulate the dynamical behavior of a system. The stability of the integration scheme of a dynamical equation is necessitates the use of a time stem, which results in, sorry, this is 10 raised to 5, okay? 10 raised to 5 Euler integration steps. Further, proper statistics dictate at least 6 of such simulations, okay? So that is, you will have to do an integration. That integration has to be done for 10 raised to 5 integration steps. Like that, you will have to do the integration at least 6 times. Okay, that is one condition. That is one case. In the other case, you see, a package is decided to be developed for a plan-wide simulation during the plan design, and the plan has 11 process units. Okay, 11 small units are there. And the plan-wide model involves a collection of transient energy, mass and energy balances, property correlations, and control equations. So here, which one do you use, compiled or interpreted language? So in the first one, if you see, so the whole thing, though we have to run for 10 raised to 5 integration step, or we have to run for 6 simulations, the basically what you're trying to do is solving an integration problem, okay? Which might be like 5 or 6 lines of the code. Okay, maybe like, let's imagine 10 or 15 lines of the code. Okay, this code you can put it in a loop and try to execute it for 10 raised to 5 integration step, and it can be again put in another loop for running it for six cycles. Okay, at least 6 cycles. So here what we have is the length of the code is very small, and you have to repeat the same code 6 times. So here what happens is you can use a compiled language. Why? Because since the whole code is small, you can fastly convert the whole thing into a machine code, and then you can execute it. Even if there is an error in the code, you know that since your code is very small, it's only 10-15 lines of the code, you can figure out where the error is. Okay, so then this is easy to debug. And since you're repeating the same code again and again 6 times, it is easy, it runs faster when you're writing this in a compiled language. But on the other hand, you will see you have to design a whole plan-wide simulation, which has like 11 process unit. And each of the units have several mass and energy balances, property correlations, control equations. So here, if you're trying to code this using a compiled language, and if something goes wrong somewhere, it will be very difficult for you to track, because there are 11 process units and each process units have several other operations. So for such systems, we would prefer an interpreted language. So in interpreted language, you can first code one process units, run it and see, do the second process unit, third process unit, fourth process unit, 11 process units and all. And you can run it at one go also. If you run it at one go also, just imagine there's an error in my fourth process unit. Okay, if that is the case, at least my first 3 process unit will be executed. And you know very clearly that, okay, right now my whole code has stopped at the fourth processing unit. So there is some error there. Okay, so such errors you can easily find out when you are working with interpreted languages. And interpreted languages, as I said earlier, it is more user friendly. So for simulating such big systems, you can always make use of such softwares like Matlab or Python. Do you have any questions?
Do I audible?
Yeah, yes.
I mean, case one, we can also use interpreted languages.
Yeah, yes. You can also use interpreted languages because it's a very easy one. But the thing is, see, as I said, combined languages are faster, right? So you have to run for 10 raised to 5 Euler integration steps. Okay, so because of the time reasons, it will be better to use compiled languages because it will be executed much more faster. Just imagine 10 raised to 5 steps, you're executing line by line. Then this might be slower compared to combined languages.
Okay.
Okay. Yes. Any more questions? Okay, now we'll be quickly going through some questions. So I'll give you like 2-3 minutes. If you have answers, you can just put it in the chat box. You'll just not unmute and just don't shout out the answers. Okay, we have to give other people also time. There are around like 18 students in the class. Different people might have different timings. So let's not disturb others. If you've got the answer, good, just put it in the chat box and we'll discuss the answers. So this week, since we haven't done any programming, the questions will be basic. Matlab basics. But since I know that there are some students who doesn't know the Matlab basics, we'll take some time. And if any of the questions, if it requires certain extra points for me to share, I'll share that. Okay. And also, since this is our first class, it will take time for me to understand what kind of audience you are, because you guys will be from the different backgrounds, and your knowledge about Matlab could also be different. So in case you have any suggestions for improvement, or if you want me to specify on any specific topic, please do let me know then and there. As you know, this will be the only live interaction that we have with this in this course. That is, we have a Friday lecture and we have a Tuesday lecture. Both of us will be discussing the same week things. But so if you, since this is the first week, let's not pile up all the doubts. If you have doubts, then and there, ask. If I don't know the answer, I'll just refer and let you know by the next class. And also regarding the recordings, yes, this meeting has been recorded, and I'll share the recordings. It will be available to you in your course webpage. But as I said, there might be a delay of a day or two. So I always recommend you to attend the live session first. Okay, so that will be like a first-hand experience. So as I said, if you have any suggestions for improvement, anything to change or anything, please do let me know, so that rest we'll have like around 12 sessions. We can have every session like better and better. Now let's go to the question. I'll just show you the question. It might be basic questions also, but I'll just give you 1 or 2 minutes. Let's take it slowly. Sorry, before that, I had to tell one more thing. So for the people, this is for the people who doesn't have a basic knowledge of MATLAB. As you've heard in the recordings of this course is not intended to teach you the basic of MATLAB. Okay, so MATLAB basic is considered as a prerequisite for this course, but I'm just suggesting you, this is not being given in the recorded lectures. This is a suggestion from my side. The Matlab itself offers a Matlab on-ramp course. Okay, you can just go to Google. This is a screenshot taken from the Google webpage. So you can just go to Matlab on-ramp, okay, and take this course. It's a free course. You can see the length of the whole course is just about 2 hours. Okay, just take the course. You'll have a course overview, and you'll have the basic commands of MATLAB that has been taught. You'll have an introduction about the MATLAB desktop, the editor window, the different, whatever I showed you, like what is the editor, what is a command window, workspace, and all those things. You'll have a basic introduction to that. Then you will have basic some vector matrices operations, array indexing, array calculation, function calls, and everything. Okay, so this is just a quick recap to MATLAB. So which is about just 2 hours, which is offered by Matlab also. I believe that you can also get a certification after doing this, okay, which you may add to your resume or something if needed. So this is just a course that is provided. So the people who don't have an prior experience to MATLAB, just don't rely on this course, because this course is not intended to teach you a MATLAB basics. But in the next week, that is in the next coming week, we'll have some MATLAB basics, which I'll be discussing. I'll be giving you questions. We'll have an interaction section and everything. But if you want something extra, you can always spend 2 hours and try to do this. Okay. Apart from this, there has been a course that is offered by NPTEL, Numerical Computation in MATLAB. That has been suggested by the professor also in the recordings. If you want, you can go visit that also. But that is a much more lengthy. It's like a NPTEL course. So it has like some 12 weeks lectures. If you have time, you can listen to that also. But if you want a quick recap into the MATLAB, you can always choose this. MATLAB on-ramp. I think there are more courses that are offered by MATLAB. There is like a machine learning course and everything. You can do this and you can get certifications also, and you can add it in the resume if you want to. Okay. Okay. Now going on to the questions. But before that, any questions? Any questions regarding the MATLAB on-ramp or anything I said before? If no questions, I have just shown you the question number 1. Just give me the option in the chat box. Yeah, good. Yeah, as I said, MATLAB stands for, yeah, I've got like sufficient answers. MATLAB stands for Matrix Laboratory. Why I'm showing you MCQs like this because if you have seen the assignment 1, your questions will be like this. Okay, you'll have MCQs. So right now, since we have only done theory, all the questions will be theoretical questions for the week 1. But from next week onwards, you can expect some mathematical questions to come. Okay, even your NPTEL exam will be like this. You will have MCQs, which may have like single choices or multiple choices as answers. So that's it. So this is the first question. Now I'll move on to this next question. So the answer is metrics laboratory. Okay. Question number 1. If you get the answer, you can put in the chat box. Yeah, got some 8 answers. Yeah, false. Yes. Compared language provide better cross-platform compatibility in comparison to interpreted languages, which is false. We saw that C and Fortran, it is like the coding is much more difficult. So the platform compatibility is not there as much as compared to the interpreted languages like Python or Matlab. So the answer is false, the option B. Now going on to the third question. Which one of the following is a system that can be best described by the spatial temporal formulation? This has not been discussed in the recording lectures, but some of the questions that have been given here I've taken from the last time the scores when the course was circulated that had assignments. So these are some example assignment questions which you could expect in the future also. Okay, if you have an answer, you can put it in the chat box. Okay, so the answer is second one, transient tubular reactor. Why? Because in continuous reactor, you know that there is a uniform composition at all point, right? So the only thing that is varying here is the temperature, concentration with respect to temperature. So there is only temporal formulation there. But on the transient tubular reactor, you know that along the tube, okay, there is a concentration variation. And also since it's transient, that it is varying with respect to time, there is also a temperature variation that is coming. Okay, so that's why the spatio-temporal formulation will be there for the transient tubular reactor. Now coming into the on-off control, there is no spatial factor there in that controller. It's just on or off depending on the time. So it doesn't have a spatial temporal formulation. So the answer is B, transient tubular reactor. Now we have another question which I want you to solve. Like just take a pen and paper and try to solve this. Should I read the question? So I'll just read the question once. It is required to prepare 1250 kilogram of a solution composed of 12 weight percentage ethanol, 88 weight percentage of water. Two solutions are mixed. Okay, so two solutions are mixed. The solution A has 5% ethanol and B has 25 weight percentage ethanol. How much solution of A is required in kgs? Okay. Also, the overall material balance equations are already given to you. Okay. So A plus B is equal to M. M is the total weight of the solution, which has been given to you in the question 1250. Okay, rest of the equations you can just think and try to give the answer in the chat box. I'll just give you like 3-4 minutes. I've got some answers. Anyone more? I'll just give you like 2-3 minutes more. So we have got some answers. Let's see. So the final answer is 812.5 kgs. Many have got it right. So the overall material balance is A plus B is equal to 1250, and the ethanol balance and water balance can be done separately. Okay. So here we have like 3 equations and we have like 2 unknowns. From there, we will be getting A is equal to 812.5 kgs. Since most of the people have got the answer right, I think it doesn't require any further explanation. In case you have any doubts, please ask. Now moving on to the next question. Compute the sum of 10 equally spaced numbers between 0 and 1 using suitable inbuilt MATLAB function. This might be difficult for the people who doesn't know the basics of MATLAB, but still you can try. Okay. And so there is an easy inbuilt MATLAB function that can help you find the sum of a series. Okay. We need from 0 and 1, you need like 100 equally spaced numbers. So yeah, I'll just give you like few minutes. Try to figure it out on by your own. Maybe you can use MATLAB itself to help you out. Then we'll discuss the answer. not got any answers till now. I'll just give you one more minute. Yeah, sure. The answer is the MATLAB command that we use is called as linspace. Okay. Now we'll see. Yeah, somebody has given me the answer. Linspace 0 to 100. So we'll just go to MATLAB and see how this linspace works. Okay. So let's go help linspace. Is it right? Yeah. So linspace is means linearly spaced vector. Yeah, the sum we'll find out. So in linspace, how do you work with it? So this is a basic syntax. The keyword is linspace, and then you give x1 and x2. What does this do? X1 and x2 generate a row of 100 linearly equally spaced numbers between x1 and x2. That is, x1 and x2 will be kept, and between that 100 equally spaced vectors will be numbers will be created between x1 and x2. Okay, in case you want like 1000 or something, user defined numbers, then you can give that also. That is x1, x2, comma, n means generates n equally spaced points between x1 and x2. So right now, what was the command that I gave? So right now the answer is linspace 0 to 100, and the sum is a MATLAB function that can give you a sum of a vector that you give. So right now we'll just see, okay, linspace 0, 1, 100. Okay, let me just type here. Okay, I'm just saving this number as num. Okay, this is my variable name. Num equal to linspace 0 to 0, 1, 100. Let me just run this. You will see like 100 values here. Okay, in the workspace also you can see num. It is having 100 values. Okay, and the what is the type of values we have? It is double integer. Okay, now you'll see here the first value is 0, and the last value, let me just scroll it. Last value is 1. Okay, in between you have like space numbers. Finally, you will have a total of 100 numbers. Okay, equally spaced numbers. Now, if you want to find the sum, you have to just find sum of num. Okay, the answer is 50. The final answer is 50. If you don't want to use sum of, if you don't want to use a separate variable num, you can directly type sum linspace 0, 1, 100. Close the bracket for linspace, close the bracket for sum. And yeah, again, you will get the final answer to be 50. So this is a MATLAB command, linspace, which can be used if you want to generate equally spaced numbers between two endpoints. Is this clear? Now moving on to the, okay, I have just a comment, yes. Okay, now moving on to the next question. Determine the number of elements in the vector x is equal to 1, 4, 9, 16, and 25. Okay, and you want the final answer to be stored in n. Which of the following statement is correct? Then I'll give you 2 minutes. I'll give you 1 more minute and then we'll discuss what this function size and everything does. Okay. So let's discuss the answer. So before discussing the answer, let me just give you a brief idea of what is vectors and what is matrices in MATLAB. Okay, there are two kinds of vectors in MATLAB. Vector means it's a one-dimensional thing. Okay, either it could be a single row or a single column. So I'll just show you in MATLAB how to do that. For example, if I'm writing in MATLAB, you should always start a vector or a matrix using a square bracket. Then I'm typing 1, 2, 3, 4, 5. If the entries are divided by a comma or a space, okay, then everything will be entered in a single row. See, it's a single row. 1, 2, 3, everything has come in a single row. It could be divided by a comma or a space. Okay, now on the same hand, I'm dividing these numbers by a semicolon. 1 semicolon, 2 semicolon, 3 semicolon, 4 semicolon, 5. Close the bracket. You will get a column vector. So this is a row vector. This is a column vector. Now, if you want to convert a row vector to column vector, you can just put a symbol like this. 1, 2, 3, 4, 5. And just create a apostrophe kind of a thing, and then you will have a row vector converted into column vector. Similarly, if you put the symbol here, you will get a column vector converted into a row vector. Now, what is a matrix? Matrix means it will have more than one dimension. It will have a certain number of rows, certain number of columns. How do you write a matrix? You will have first, you have to write the first row first. So it will be 1, 2, 3. That is my first row. Then I am going to the second row. For that, you'll have to separate into columns. You have to put a semicolon. Okay. Then 4, 5, 6. That will be my second row. Again, put a semicolon. It will be 7, 8, 9. Now close the bracket. So this is a matrix. It has 3 rows and 3 columns. Okay. Now what does this command size does? Help size. Okay. Size gives you a size of an array. For example, if you are giving size and inside that bracket you are giving x, x is an m by n matrix. Okay. So the size it will give you, the size will return a 2-element row vector. So for example, this thing, let me just give a equal to, okay, and I'm typing size of a. You will get 3, 3. Okay, remember the first number gives you the number of rows and the second number gives you the number of columns. If you have doubt, I'll just create one more. 10, 11, 12. Okay, now it has like 4 rows and 3 columns. Now again, I'm using the size command. You will get 4 rows and 3 columns. Okay. And in MATLAB, there is one more trick. If you can use the up arrow, okay, you will get all the previous commands that you have typed in the command window. Okay. If you are typing more like lot of like 10, 15 lines, it will be very difficult to track. But if you just want to get the previous command, you can press on the up arrow and you will get the previous command. Okay. Size A is 4 rows and 3 columns. Now earlier, whatever we had was a single row vector. So let me just type this one. What was it? It was 149, 16, 25. Okay. So that is A is equal to, okay. Sorry, let me just type B is equal to 1, 4, 9, 16, 25. Okay, so this is the answer thing we have. Now we need n equal to size b, 1. Okay, so b, 1 means the b, whatever it is a vector or a matrix. 1 means the first dimension. First dimension is the row dimension. Okay, this is the first number. First dimension is the row dimension. So this will give you the number of rows. Let us see what the number of rows is. So this thing only has 1 row because it's a row vector. So n is equal to number of rows, that is 1. Now, what if I want to have the second dimension, which is the column dimension? So here the second number that we get is a column dimension. So again, I type b, 2. I get 5. So that is 1, 2, 3, 4, 5. 5 columns I have. So n is equal to 5. So here in this case, the question was when you execute which command, you will get the number of elements. What is the number of elements here? Number of elements is 5. So only if you execute the second command, you will be getting the number of elements and n to be equal to the number of elements. So the answer is n equal to size, whatever vector it is, 2. Which option was it? I think it's option B, right? Sorry, it was option A. That is n equal to size x comma 2. Any questions? Okay. Now moving forward, this A is the answer. Now you can, if you have MATLAB, you can just evaluate this command and see what will be the answer. So eval is like a MATLAB command. What it does is it will execute what is written in the double quotes. So you can just quickly, you can tell what is the answer for this question. Yes, the answer is 8. Okay, it will be evaluating this command, that is x is equal to 5 plus 3, that is 8. Now moving forward, which of the following are valid commands for different graphing features in MATLAB? What you can do is you can just go to MATLAB and type help or something and see if all these 4 options are available. And if any of them is not available, you can just tell me. The question is, what is the valid commands? I've got some answers. The actual answer is all. Okay, if you want, you can just go type help histogram, help surf, and help bar 3, help counter 3, and all those things. Actually, all this plots are available. Okay, you can draw a histogram, you can draw a surface plot. Okay, and there is bar 3H, and this is a contour plot. You can get, sorry, you can get all these 4 options available in MATLAB. So right now, all the 4 options are valid commands in MATLAB. So the answer is all of it. Now, give a quick answer for this question. Yeah, many of you got the previous answer right. Now, question number 9. Yes, the answer is B. Many of you got it right. So it will be x is equal to 2 multiplied by 3. So x is equal to 6. And after that, you execute y. So y is equal to x multiplied by 2. Since x is already 6, 6 multiplied by 2 is 12. So you get y equal to 12 and x is equal to 6, which is the option B. So in MATLAB, you have to execute commands line by line. Option is B. Now moving on to the next question. Which function is not provided by MATLAB mathematical function library? This also you can check and let me know. So the answer is D. That is which function is not provided in MATLAB. Actually, all these functions has been provided in MATLAB. So Bessel functions, matrix eigenvalues, Fourier transform, all this can be handled by MATLAB. So the answer is D, none of the above. Now, which is a invalid variable name in MATLAB? Yeah, most of you got it right. So the actual answer is C. That is, so we'll see. So you can't have x6 is fine because always a variable name in MATLAB has to start with a alphabet. Okay, it shouldn't be starting with a number. So that is why option C is the answer. You can't start with a number. X6 is fine. Like you can have like x1, x2, x3, x4. All this can be used as a all this can be used like a MATLAB variable, just that it has to start with an alphabet. And one more thing you have to keep in mind is that there are certain inbuilt MATLAB functions. For example, you would have seen sum. Sum is an inbuilt MATLAB function which calculates the sum of the elements in a vector, elements in a matrix. Okay, so make sure when you're trying to code, don't use any inbuilt MATLAB commands. Like don't use your variable name to be sum. Instead, you can use something like that, like sum1 or sum2, something like that. So maybe s can be used as a variable name. So don't use the inbuilt MATLAB commands as a variable, it might not show an error, but the problem is the variable that you wrote and the inbuilt MATLAB command, it might overlap. So if there is an error, you will not be able to figure out what is going wrong. So try to not use the inbuilt MATLAB commands as your variables, and you can't start a variable name with a character or a number. It always has to start with a alphabet. Okay, I hope that is clear. Now, which of the following is an interpreted language? So many have given me an answer. So Ruby is the interpreted language. Rest are like compiled languages. You can just go and Google it and see. Okay. Now in MATLAB, which command is used to add text label to the x-axis of a plot? Okay, you can draw plots and then it has x-axis and y-axis. Which of them is used for adding the command, adding the text to an x-axis? Okay, many of you have got it right now itself. The answer is B, X labeled. So before that, let's just quickly go and see what this plot command does in MATLAB so that those who don't know will get a brief idea of it. So the best thing is here in the, I'll type plot. Can you see this? Okay. So now plot, I'm just clicking on this. So this is how this is a MATLAB plot command. There is a plot thing, and then you can give x-axis and y-axis values. You can also specify how the line should look like. For example, if you have the x values like this and y values to be the sign of respective x values, then the plot xy looks like a sine curve. Now, if I want to plot two curves, I can just plot x and y axis of the first line, x and y axis of the second line. So both will come in a single plot. Now, if I want to plot from a matrix also, you can plot it. This you can refer. Okay. Now, if I want to specify the type of line I want. So x and y, if you don't specify anything, it will be like a solid line. Then the x and y, next line x and y should be dash dash. This means you will be getting a dashed line. Okay, that is this red one. And then x, y3, which is the third line, and I've given you two dots. This means your third line will be a dotted line. So this is how you specify the line type. Now, if you want to specify the color, X and Y, G means it is green color. X and Y, B dash dash O means it should be B stands for blue. It should be a dash dash line with circles in between. X and Y, C star means C is called a cyan. It's like a tint of blue color, and it will be a starred line. And similarly, you can have different ways in which you can plot the line. You can have like line width can be varied. The size of the markers can be varied. It is stars or squares, or it can be varied. It can be all, you can also vary the edge color of it, the face color of it. A lot of things can be played around. Now, if you want to add titles and labels, okay. So this is a plot. X is the lin space. You have from 0 to 10, you have 150 equally spaced points. Now the Y is nothing but the cos of these values, okay. Now we are plotting XY color 0, 0.7, 0.9. Now the title is, to add a title, this is the keyword title. You give the title in a single quotes in a bracket. Now if you want X label is a title for adding X axis label. In single quotes, you add the label. Y label, if you want to add text to the Y axis, in single quotes, you add the text there. So finally, you will be getting the heading to be 2D line plot. The x-axis entry will be x, and the y-axis you will have cos 5x. So these are the keywords: title, x label, y label. Now you have like more options that are available, which you can go here and you can try to figure it out. Okay, just take some time, and you have like several options that are available here. You can go see each of them. Now going back to the questions. So the answer is B. Now, which command will return the corner elements of a 10 by 10 matrix A? Okay, so this is a bit tricky question. Take some time and try to answer this question. So A is a 10 by 10 matrix, that is 10 rows and 10 column, and I need to get the corner elements. This is how to access the entries of matrices. If you don't know, I'll discuss this while discussing the answer. But those people who know it can just try to figure out what the answer is. So many have given the answer. Okay, there are mixed answers actually. We'll see. I'll give you 2 more minutes and then we'll discuss the answers. So let's see the answer. Okay, so first we need to know how to access a matrix. Okay, how to access certain elements of a matrix. So here, first and foremost, let's create a 10 by 10 matrix. Okay, just give me a second. Sorry. Okay, I hope you can see it. Let me just clear all the variables. Clear means it will clear the command window. Sorry, it will clear the workspace. If I want to clear the command window, I'll be like CLC. Okay, now everything is cleared. Now I'm creating a matrix A, and I want to create a 10 by 10 matrix. Right now, I'm not worried about what the numbers are. So I'm creating a random matrix. So the keyword for creating a random matrix is RAND, and then you have to mention the size. Okay, if you just mention one number, it will create a n by n matrix. So if I'm mentioning 10, it will be a 10 by 10 matrix. If I want a 3 by 4 matrix, then I have to give 3 comma 4. Right now, I just want a 10 by 10 matrix. So I'll be just typing semicolon means I don't want it to be printed here. Okay, because it's a 10 by 10 huge matrix. So, okay, now you'll see here. A is a matrix. It has 10 by 10 values. Open this. You will see here 10 rows are there and 10 columns will be there. See, 10 columns are there. So this is a 10 by 10 matrix. Now we'll have to access elements of a matrix. If you want to access elements of a matrix, for making a matrix, there are some inbuilt functions like this, or else you have to use a square bracket. But if you want to access a number from the matrix, you have to use a round bracket. First round bracket, you have to enter the row number, maybe the row number is 2, and then you have to enter the column number. Okay, I want the second row, third column number. Okay, now the answer is 0.2279. We'll check if that is correct. A second row is this. Okay, second row is, second row is this. In that, I want to get the third column, first, second, and the third column. Okay, so this is the number 0.2279. So if you see here, that is the answer. Second row and third column. Now we'll see what happens if I give a number like this. A. In the first bracket, I'm giving a vector 1, 2, and then I'm giving another vector 3, 4, and again closing it. This will give me 4 values. What is this? This means I have access to the first and the second row and the third and the fourth column. Okay, first and the second row and the third and the fourth column. Let's take it here. First and the second row is what? First row, second row. Okay, what is the third and the fourth column? Third column, fourth column. So basically, I'll be getting first row, third column, first row, fourth column, second row, third column, second row, fourth column. Basically, I'll be getting access to 4 values. So go first with row wise. So first row, first column, first row, second column, then second row, first column, second row, second column. So it will be this one. First row, first column is 0.1101. First row, second column is this one, the fourth one. So that is 0.3376. First row, sorry, second row, third column. Okay, that is this one. Third column is this 0.2279. Then second row, fourth column. That is this 0.9429. So this is the elements that you get. Now let us look at the questions. So you have a 10 by 10 matrix and now we want to get the elements. So let's see the first, the actual answer is A option. Okay. So the actual answer is this because here you'll be getting first row, say last row, and is a keyword that gives you the last row or the last column, wherever you give it. If you give it in the first part, in the row part, you will be getting the last row. If you write it in the column part, you'll be getting the last column. So end is a keyword that helps MATLAB identify whatever is the last column or the last row of a matrix. So here you have access to the first row, last row, then you have access to first column, last column. Okay, let me enter this like this. So A, open the round brackets. I have first row, last row, comma, first column, last column. Okay, so this is what you will be getting. You will be getting A11. So that is first row, first column, that is 0.5086. then first row, last column. So that is this. First row, last column is this 0.6331. That is 0.6331. And then is last row, first column. That is this one. Last row, this is the last row, 10th row, first column 0.9297. So that is the next one. And then last row, last column. That will be the last one, 0.1616. So this will give me all the corner elements A11, A110, A101, A1010. Okay, any doubts in this? You can see what the other commands does, but this is the answer. Any doubt in how to access the metrics? Okay. So now we have a quick question. Which of the following is an assignment operator in MATLAB? How do you assign a value to a variable? The option is B, equal to. Okay. So equal to is an assignment operator. Equal to is like a logical operator. That is, you check, right? If A equal to B means you check if it is logically right. You're like, it is equivalent to A greater than B, A less than B, A equal to B. Yes, you're just checking if both are equal. It's a logical operator. The answer can be either true or false. Okay, that is not an assignment operator. Assignment operator is A equal to. Now, which character is used to print a new line in an fprint statement? This might be new to some people. So if anybody knows the answer, you can just type, or else I'll just explain. Yeah, many gave me the right answer. The answer is \n. This option is for entering a new line. Fprint is a statement in MATLAB which helps you to print some line, okay, during an execution. So that is \n. Now a basic question from the chemical engineering perspective. Energy conservation determines which profile? Yeah, many have got the answer, right? Energy conservation here determines the temperature profile. That is option B. Now the next question, momentum conservation determines which profile? Yeah, so the answer is velocity profile, option C. Now a quick next question, mass conservation determines? Yes, the concentration profile. Now Navier-Stokes equation expresses which balance? Yes, the right answer is momentum balance. Now, the spatio-temporal model should have, choose a right option. So yes, the option is C. I think why did many of you get it wrong? See, there are two types of things. It should be an independent variable is there, dependent variable is there. Independent variable is what that comes what the basic thing depends on. So for example, earlier we saw how the temperature varies with respect to time and space. Okay. So here time is an independent variable, space is an independent variable. What is a dependent variable? Temperature is a dependent variable. Okay. So in a spatial temporal model, we'll have both space and time as independent variable, not as dependent variable. So it's option C. Now another question, which of the following properties does not affect the Reynolds number? Yeah. Everybody got it right. Specific heat of the fluid. It's not dependent on that. Now, which of the following command is used to stop the execution of a MATLAB command? Imagine you are running a MATLAB command which is running forever. You want to forcefully stop it. Which is the shortcut for that? So the actual answer is Control C. Yeah, that is option B. Yeah, of course, some of you have got it correct. So if you have a MATLAB code that is running forever, if you want to forcefully stop it, you can just type Control plus C. Okay, that will stop the execution of the MATLAB command. Okay, this I have repeated several times right now in this lecture. Which command is used to clear all data and variables stored in the memory? That means clearing the workspace. What do you use? Yes. You use the B clear. Okay, CLC is for clearing the command window and clear is for clearing the workspace. Workspace is where you have all the variables and the values associated with it stored. So for clearing the workspace, you use the command clear. Now, which of the command is used to add a comment in a MATLAB code? No, I think most of you are getting it wrong. I'll just tell you the actual answer is option A. If you want. Sorry, there is a mistake. I think most of you are getting it wrong. So here, just imagine, I'm just typing here a comment, okay? So it's like computing lines, something like this, okay? So comment in MATLAB starts with a percentage sign and it comes as a green color. And these comments are not executed. Even if you enter comment 6 multiplied by 7, this will not be executed. Now I'll just run this. Either you can just, you can click it here and you can press run. Okay. Now you will see trial this thing, the code is ran, but the first two lines, computing lines and 6 multiplied by 7 is not computed. The first answer that you get is 1 multiplied by 2, 3, then 2 multiplied by, so 1 plus 2, 3, 2 multiplied by 3, 6, and 4 multiplied by 6, 24. Okay, so this is how you enter comments in MATLAB. If you want to divide into sections, you can have 2 percentage signs. So if you put 2% signs, you will see a line here. Okay, line means this is a section of MATLAB, this is a section of MATLAB, and you can execute sections separately. Save this code and just click on this and you can see run section. Instead of running the whole MATLAB code at one stretch, you can put double percentage sign and divide the whole code into sections. For example, here, I'm dividing the whole code into sections. So this is one section, this is another section, this is another section. Let me clear all this CLC. Now click on the first section somewhere and click run section. Now you'll see only the first two commands have run. Now click on the second section and again click on the run section. Now the third command has been run. So this is if you want to divide the entire code into sections, you'll have to use double percentage. If you want to have like comments added, you will have to use a single percentage sign. Now a quick question. Find the eigenvalue of a given matrix A is equal to 1, 8, 2, 1. So since we have already crossed 8 o'clock, I'll just quickly give you the answer. Okay, if you have a matrix to find the eigenvalues, that's an inbuilt MATLAB command, which is called as EIG. Okay, so first you enter the matrix here, E is equal to 1, 8, semicolon, you enter the next row, 2, 1. Okay, this is the matrix. If you want to calculate the eigenvalues, you type the command EIG, then give the matrix in it. You will get the eigenvalues. So eigenvalues are 5 and -3. So that is go back. So the answer is it has 2 eigenvalues. Okay. Now I think this is the last question. Find the eigenvalues of the matrix 4, 1, 3, 1, 3, 1, 2, 0, 5. If you have access to MATLAB, can you quickly find it out? 4, 1, 3, 1, 3, 1, 2, 0, 5. I didn't get the answer. Somebody. So the matrix is A equal to capital, sorry. I'm sharing MATLAB, right? Yeah. So the matrix is A equal to 4, 1, 3. Next row is 1, 3, 1. Next row is 2, 0, 5. Right? Am I right? Now again, you have to find the eigenvalues. EIG A. You get the different eigenvalues, out of which I think only 3 is given in the option. So yeah, many of you have given me the answers. So yeah, one person have given me the whole eigenvalue. So the answer is A actually. So that's it with today's session. So today we had a brief introduction of why use programming and we had a brief introduction to using MATLAB. I think next week the course content is we'll be having a much more deeper basics into MATLAB. So before that, if you want to have a quick recap, you can go to the MATLAB on-ramp course or you can just Google and try to learn things by your own. I hope this session was useful. So in case you have something to improve, like if you have to tell me like some improvement points, also I am happy to take it. So any other doubts or else we'll close the session. You're welcome. Which book can we use for MATLAB? Actually, I'm not suggesting you any book. You can go to the course webpage and there will be course materials that are suggested. Use that. But to be very frank, I didn't use any course materials. I went through this, as I said, I started with the MATLAB on-ramp course. Then I did like few other MATLAB courses and again did the what sir suggested, right? The course that is numerical computation in MATLAB. I took that course. I was a TA for that course. So that's how I learned MATLAB. So there are books, but I'll ask you to go with the sir's suggestion, okay? The professor's suggestion for the course. Ma'am, will you post this video on YouTube? Yes, I'll post this video on YouTube. I'll send the link. It will be available here. I'll just show you where the link will be available. Just a second. So this is your course webpage. Sorry, here. Okay. Below this assignments, you will have a section here. which will tell you problem solving session. And in that, the YouTube link and the PPT, which I'm showing you right now, will be shared. But as I said, since the course has just began, it might take some time to be uploaded, but I'll send it today itself. Okay. Any more questions?
Semicolon is used.
To
Hello?
separate a column. Yeah, to go to the next
Yeah,
column.
used for the column case, okay?
Yeah.
And when we use for the column,
When we use for the
when we use the colon command,
colon command, I don't actually. The column means you meant the comma.
there was a no colon.
Can you just, I'm not getting which, like, can you just put that on the chat box, which you were, what you were intending?
There was a question.
There was a question.
I written colon.
Yeah, okay.
There was a question in which the option D it was used was the corner
Okay.
element question. Corner
Yeah, fine,
element.
fine, fine. Oh, this one. Oh, okay. I was like, this option, right?
So
So
yeah,
colon means it takes all values from 1 to end. Okay, colon is a operator in MATLAB that is used to define a series of a vector basically. So one colon end means it will take 1, 2, 3, 4, 5, 6 till what the end is. So for example, in MATLAB, if you type 1 colon 5 or 6, okay, 1 colon 6 means it will give you 1, 2, 3, 4, 5, 6. Okay. If you
okay.
want this colon operator not to be, so here what is the difference between the numbers? 1, right? 1 plus 1, 2, 2 plus 1, 3, like this. If you want a different difference, so I want it to be jumping by a difference of 2, then I can give like this, 1 colon 2 comma 10. So this means I'll go from 1 to 10 by the step, but the step will be 2.
Okay, steps as will be 2.
Yeah. You can go the reverse also. If I want to go to 10 to 1 with a difference of minus 2, I can do this. So it will become 10, minus 2, 8, minus 2, 6, minus 2, 4, and minus 2, 2. After that, minus 2 means 0, right? But 0 will not be there because I have to stop before 1.
Okay.
Okay?
Thanks.
Yeah. Sure. I hope there are no further questions. And please do attend the next session also. So if you have any questions, it's solved then and there. So thank you all for attending the session. If you don't have any questions, you can leave the session. And I'll be sending the recording soon.
And what does n value calculate?
N value? End. You're talking about end?
Yes, ma'am. The last question and
Yeah.
the second last.
So the end means the MATLAB, it's a keyword that MATLAB uses. If end is written in the columns, this is where you enter the row numbers, no? If end is written in the rows space, it gives you the last column number. And if it is entered in the column space, it will give you the last row number, and this gives you last column number. End is a MATLAB keyword. If you don't know what is the size of your array, here it is given you 10 by 10. But what if you don't know what is the size? Okay, then you can give the keyword end. MATLAB will automatically get you the last row or last column.
No, ma'am. I was asking about the last question that you gave. N value. I.
N value I. Just a second. I'll just. N value I. Which was that? Remember the question number?
Yes, ma'am. Eigenvalue that 27 or 20.
This one?
Yes, ma'am. Yes. Yes, ma'am.
Here, what is your doubt?
Ma'am, what does eigen value calculate?
Oh, eigenvalue of a matrix. So eigenvalue of a matrix is, you can go try to recap what is matrix, eigenvectors, and eigenvalue. Okay. That is, every matrix has its own eigenvalues. That is like the independent vector directions. And then there is a value associated with it. So that is like called as an eigenvalues. So mathematically to the base, I'm not actually going because of time constraints, but just try to look up what is eigenvalues, because that is not specific to MATLAB. Okay, it's a matrix property. Like you say determinant. Okay, you have eigenvectors and eigenvalues. Okay, try to see if you can find it, and if you still have doubts, just we'll take up it in the next lecture. Okay. So this is like, it's a bit complicated. It is associated with the, what you say, the transformation of a matrix. Every matrix can be transformed with respect to like independent vectors and everything like that. It can be a little bit complicated, but it's like a matrix property. That's what I can say. Yeah.
And one last question.
Yeah, sure.
The assignment will be given to us. So how we will submit that? What?
You can enter so there is a space where you can select all the MCQs, and finally there is a submit button, right? In the bottom.
CQ type of question.
Yeah.
Okay. Thank you, ma'am.
Yeah, sure. Okay, thank you all. I'll be closing the session. We'll have the next session Friday, 6 to 8 p.m. Okay, every Friday, 6 to 8 p.m. in the same link, we'll have the sessions. Thank you.
Ma'am, if you don't mind, can you show again where will you be posting this video?
Yeah, sure. Just a second. So here, no, where you see week 1, week 0 courses, here there will be another section which will come up. I'll send it. Actually, the NPTEL people has to upload it. It will be a written problem solving session. There, when you click, you will be getting the link.
Thank you, ma'am.
Okay. Yeah. So I'll be closing the session. Thank you all.